Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's ContainerJournal.com webinar, brought to you by Techstrong. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting panel ahead of us, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded. So if you miss any of our discussion or you like to rewatch, share, re-listen later, the recording will be made available shortly after we conclude our live webinar today. If you have any questions, we want you to send those in using the Q&A tab on the right side of the screen. That's also where you're going to find the chat tab. And this is where we want you to engage with our speakers directly, help influence our discussion today, and let us know all your feedback there. And finally, at the conclusion of this webinar, we will be giving away 4 $25 Amazon gift cards. So be sure to stick around. Our topic of discussion today is simplifying container networking with eBPF. And joining me is Stevie Caldwell, tech lead at Fairwinds, Josh Hogue, senior sales engineer at Strong DM, Jared Curtis, cloud architect at Everbridge, and leading our conversation today is Mike Vizard, chief content officer here at Techstrong Group. Jared, Josh, and Stevie, Mike, thank you all for being here today. Mike, I'm going to let you get us started.
All right. Well, it's not clear to me that everybody knows exactly what eBPF is all about. So we're going to start with Stevie, who's going to give us a little bit of an explanation of what, if I'm not mistaken, it's extended Berkeley Packet Filtering in the kernel.
Yeah.
How is this going to change our world, man?
Everything's going to be great. It's going to fix everything. All of our problems will go away. I think we sort of agreed in our little group here that eBPF is, at a high level, magic sauce that goes all over all of your problems. So, it stands for Extended Berkeley Packet Filter. And the idea is that it allows you to essentially program the kernel. So there's this concept of on a system, there's a delineation between what's called user space, which is where your programs run, your web browsers or, your CLI commands. And then there's the kernel space, which is protected. That's where your low level system things run. And eBPF actually allows you to write code that can get loaded into your kernel and do things for you at different points of like the kernel processing. So you essentially write this code, it gets verified by this sort of virtual machine, which is the eBPF portion of it, and then compiles it and then hooks into various places in the kernel and essentially runs your code when when certain events happen, and then has the ability to change things, like change packets. It could work on like a network level. It can do a lot of like security things, network policies, all sorts of stuff can be done via writing eBPF. So that's the high level overview, I think. Is that sufficient?
That was great. It creates something of a safe space within the kernel for you to actually write something yourself or for a vendor to write something. And that would be much faster than just putting something in the user space where a lot of stuff currently resides. Josh, when do people encounter or see this, or when would what was your first experience with it, and how did you discover it, and when do you think other people will see it?
Yeah, like I at least for me, my very first time I saw BPF displayed in a terminal or written anywhere was when I started toying with Wireshark and TCP dump, because there are actually, in order to run that, especially on the older machines or the smaller platforms that are less capable, that is exactly where that technology, at least first hit, came across my, what is this? So, I guess in that context, it makes total sense. If you're trying to use a really small embedded computer to look at an interface worth of traffic, this is that's the magic right there, is that we can bring it down to the kernel level and really make very discrete or small platforms do amazing things.
Mm-hmm. Jared, So the topic here is simplifying container networking. So we've established what eBPF is, but what will be the impact on container networking? And for that matter, if it's at the kernel level, will we see this have implications for security and storage?
Well, what's the implication to be here? Well, the thing is, we're going to have a lot more performance, right? So now instead of dropping into user space every time you want to process a packet, do some sort of firewalling, we can do that all at the kernel level now in a programmatic way rather than writing a kernel module for every special use case. You can have an eBPF policy or filter. There's going to be better performance. And as you mentioned with the security aspect, as Stevie mentioned earlier, it's like you could hook anything, right? Almost any syscall can be hooked. So you can investigate writes, you can investigate lookups. Every syscall you can monitor, filter, modify. So there's definitely going to be security benefits. I think you see a lot of players out there right now looking at that. There's also, could be malicious if get the right actor in there. But that's part of the VM that eBPF provides. It's supposed to validate that your program is, doesn't have too much complexity or does anything malicious.
You mean that something could go wrong if we allow people to program stuff at the microkernel level? I'm shocked.
I would never say that. I mean, everyone is fully trustworthy and only does the best things possible.
Yeah.
Well, isn't that where things get scary? I mean, when you mention, well, we're going to need kernel level hooks. Like I'm a vendor and I'm going to bring in a product, and by the way, this is going to have kernel level hooks. That's, you see the shoulders start to come towards the ears sometimes, and people are, like, oh, this makes me nervous because that's the core of what is making this VM or this, this container run.
Yeah, I could definitely see a few people getting nervous about that. At the same time, it's like, if you got a new storage array and they ask you to install a driver, you're not going to most people aren't going to freak out. But if you have them asking to install an eBPF program, then I go, oh, what is this? And get a little nervous.
Well, I think that part of the difference there will be, though, that installing drivers is like a thing that lots of folks are used to. Like you said, this just sort of gotten used to doing that sort of thing. But you hear eBPF and you hear program the kernel, and that can definitely make a few people wait, what am I doing to the kernel? Even though we know kernel modules and all that, right? It's still new territory, and this idea that you can just write a program and have it do stuff for you in the kernel I could see being a little nervous about that. And we've seen I found that we've seen security issue with the verifier, for example. There was a point in time when the verifier allowed wasn't as stringent as it is now, and allowed some bad stuff to happen, a few years back. So, that's the kind of thing that you hear and you go, wait a second, maybe I want to be careful about this. I can understand people being a little cautious about something that's new and this powerful.
Networking in the land of Kubernetes and containers is different than it is in traditional environments anyways. A lot of the networking protocols are handled at least internally by the cluster. And then when I connect different clusters together, I need an overlay, right? And that overlay is maybe what's going to start moving deeper into the kernel. Or what is the difference between how we think about networking within a Kubernetes cluster versus between clusters these days? And does that change the way we want to think about eBPF? So Stevie, Jared, anybody want to take a shot at explaining the nuances of networking in Kubernetes land is slightly different?
What can we say here? So when you have a standard kube cluster, it's on its own little island, right? It's its own place. And what's an external process doesn't necessarily how to talk directly to any internal pod, right? So you need to expose some sort of load balancing service or ingress to bring your traffic into your cluster. And if you want to start doing cross-cluster stuff, where you have a control plane that spans two clusters, that's just not in Kubernetes right now. So that's definitely something where eBPF can play at all the levels because it hooks the kernel, right? So you could have there's vendors who are doing load balancing using eBPF. I'm sure there's vendors who are doing cross cluster control plane, not control panel.
It's funny. I was actually thinking this and like, oh, well, like pod to pod is one thing, or like just local, network ops are one thing. But then like oftentimes we talk about how services are involved when there's external communication. So to me, all of this begs, like some of the complexity that you engender when you bring on multiple sidecars. And I think that's a huge, or just that is one of the things that strikes me as being very attractive here, is if we can eliminate some of that complexity through this. I don't know if that trade-off is exactly possible right now, but I'm really hopeful for it.
Mm-hmm. Well, guys, do we use sidecars because it's convenient and that's an easy way to kind of add something, but it adds a lot of overhead, to Josh's point. So are we going to, Jared, do you think, or Stevie, that sidecars are kind of a moment in time that we're using them, but they're going to disappear as more things drop into the kernel? Or will sidecars always have some sort of role in our world?
I mean, I think there's probably always going to be some reason to use sidecars, but I think that the emerging technologies that we're seeing now will help mitigate some of the need for that. Like the most common use cases for sidecars are things, like service meshes, so that they can inject and intercept traffic going to the container, right? And so you have something that lives in the same namespace as your microservice container, so that it can, use that same networking stack. And if you are bypassing that, using some sort of eBPF plugin that is able to listen like at the network, almost a network hardware layer in the kernel, and then bypass all that stuff and go directly to the container, then you don't need a sidecar anymore. And that removes like extra hops and things like that, and makes things move along more quickly. Same thing with, there's some solutions I think out there that do have the ability to sort of talk at higher layers of the stack. So things that you use sidecars for, like offloading logging and things like that, could also potentially be replaced with eBPF technology and hooks in the right place. So I think we'll see a decrease in reliance on sidecars, but I don't think sidecars will ever necessarily, I don't think they'll go away, because they are very easy to just do. Like, you deploy a Linker D to your cluster, you have sidecars, and voila, you've got service mesh. So I don't think it'll go away necessarily.
Do you guys think that, if I look back in the history of time, right, when the hypervisor first came along, it kind of sat up as, it was basically a hack of an instruction set, and then eventually it got optimized and dropped deeper into the chip level firmware, and then the OS guys started using it. Is this the same conversation now? We're just kind of following that same model, where more things are going to sediment themselves into that operating system level, and there'll be more optimizations at the chip level for eBPF things. And this is just the natural course of events. I mean, on the one hand, it's scary, but on the other hand, isn't this just how IT kind of evolves? Josh, what do you think?
I was having a really sort of an inside baseball thought there, which is like, well, how do we know that that's not already happening with all the custom silicon that's out there in the the globals like Google and Netflix and Meta? It may already be, right?
That's true.
Just not public, right? So like maybe Intel and AMD will come along for that, and I think you're right, that is definitely out there. Just an interesting thought. Like maybe it's already there and we just don't know it.
Maybe. All right, Jared, let's think about this a little bit further down the road. So I've got now a raft of not just networking software, but I've also got all this storage and security stuff. And it sits up in this user space. Is all that stuff rapidly going to become antiquated? And should I start thinking about, my next generation of all that stuff needs to be more like an eBPF plugin, and we are going to start ripping and replacing, what amounts to, when you add it all up, billions of dollars worth of software infrastructure that's going to be fundamentally different, because eBPF is going to show up not just in Linux, but Microsoft's committed to put it in Windows. are we on the cusp of some massive shift here?
I think this industry sometimes moves a little slow here. So I think some of the smaller players will definitely be, relying more on eBPF and be able to move faster. And some of the bigger players are going to take some time to catch up. That being said, there's a lot of benefits you could gain. So, we were talking about sidecars and maybe moving some of that sidecar logic, moving into an actual eBPF program. There's definitely an advantage to that, right? So if you've proven a technology in a sidecar and it works, why don't we move it down to the kernel layer and get better performance out of it and deeper integrations? So there's definitely some ways we can make this work. Are vendors going to rip out and replace billions of dollars in networking equipment to take more advantage of eBPF? I don't think so. Not in the near future.
No. But the first vendor that gets there with something that feels a little more turnkey may force everybody else's hand, because everybody will be like, oh, well, my networking stuff is 10 times faster than your networking stuff. And we just can't have, we're the Joneses, right? We got to keep up with the neighbors.
Yeah, definitely. That's possible.
Stevie, as you think about this for a minute, it's in the kernel and it's programmable. And historically, we had different job functions. We had network specialists, of course, and to a certain degree, we had security and storage specialists. But if everything becomes a little more programmable, will it just become net ops and security ops and storage ops is all just going to be part of DevOps because it's all going to be one programmatic motion? Is that kind of where we're headed with this?
I don't know. I mean, I feel like there's often a desire to consolidate roles. But I think that and this is probably a little bias on my part, because I used to be like a network admin way back in the day, and did my time with like Cisco devices and all that jazz and setting up hardware firewalls. And while there is, the idea of making NetOps more programmatic, making networking more programmatic, making it, involving the whole infrastructure as code philosophy there's also still an underlying, I think, knowledge about networking in general that is at play here. So I think that's the thing that makes me hesitant to say that we can just lump these all in together, right? Because I think there's still going to be a need for people who really do networking at like, a really low level, who understand like the way things are running across the wire. I think they should be playing together the way that like DevSecOps plays together. Like everybody should be part of like the general workflow. I don't think it's like a replacement merge type thing. I think it's just going to be everyone working together.
We don't all work together all that well at the moment. Will that get better as a result of all this, so that we can have specialists work a little more hand in glove? And in the absence of a super generalist that can program everything, can we get at least to some level of collaboration where we're at least playing with the same core technologies? Because it seems like part of the issue with all the specialists out there is networking software is unique in its own attributes and isn't really part of the same kind of motion as everything else. So if everything's at that kernel level, can we have that kumbaya moment, Josh, and maybe all get together and work as a true team?
Just like sort of rolling that idea over in my head, I think about, your typical war room situation where, some incident has happened, right? And we're all trying to figure out, I think the term is mean time to innocence. It's like, oh, is it the firewall team? Is it, is the networks, like who done it, right? And I guess that was sort of my, like, one of my overriding ideas there is like, okay, if we let this stuff like eBPF is in the kernel, right? And we can do these, like the bytecode that we're producing with BPF can do these really incredible things for us. Do we have the visibility that we need? And is that if once I can provide, hey, this is what my code did, then, can we get together in a meaningful way, or is it still inaccessible to you as, a DevOps practitioner versus a NetOps practitioner? Can we make it visible enough that it's understandable that you can have that kumbaya moment? So I think visibility and sadly logging is often the like a lagging thing. Like, hey, we want this product or this software to make, to do something. They often don't think about, how do we know what it did? So yes, maybe we can't all get together, but I think there's a few if thens before that.
I think there's definitely a chance for some collaboration here. The kind of the new hotness with network switches is moving to the white box switches. Those are all running some sort of variant of Linux. Microsoft Sonic's all run everything in containers, and so are they? I don't know. I'm sure the answer is yes, but I'm sure they're doing a lot of work in eBPF to write these high speed, wire rate programs that modify traffic in flight. So that to me sounds like now we have a bunch of network switches that are all running Linux that are doing eBPF. And is it the network team who runs that? Is it the ops team? Is it the NetOps team? Is it, we keep mudging words together till we find the solution?
Yeah. Well, how do we have confidence to tell Mike, back to your question, or you're bringing up virtualization, right? That was some sort of, hack initially, but then people said, hey, this can actually make our ops safer. Like, if I'm not really running this on the bare metal, how does that make my life better as an operator? I feel like there's a similar story here with BPF. Is it able to make my operations safer than, say, running a sidecar, or cheaper, for example, than bringing in some sort of physical piece of equipment? And so I think all of that is relevant in the future story here.
All right, but it doesn't sound like I should rush out and go get that devsecnetstoreops.com URL there, right? Because
somebody probably already has it.
that may take a little while. Jared, I'm going to posit something different. I think that this is going to move faster than we think, and there's two issues in my mind that will drive it. One is the performance issues around scale and networking environments isn't going to hold as we get more extended and we start pushing more stuff out to the edge. And so we need something that is fundamentally faster for networking, especially as applications become more extended. And then I would also posit that our security software is being overwhelmed by brute force attacks, and we don't have the ability to actually process things fast enough to combat those attacks, because people are putting together bots that have, large numbers of network components on it, and they're just overwhelming the existing security software that runs in the user space. So have we reached a point maybe where there are kind of two critical things happening that are going to drive this thing faster than we think?
Yeah, there's a lot of words there. Yeah, I think so. I was reading over the docs on a few projects here, getting ready for this talk, and Calico, they talk about in their standard deployment, they get 10 gigabits. That's what you get. If you move to the eBPF data plane, you get 40 gigabits. Right now, you drop a few features, but they're pretty much fair, feature complete on both sides, and you get 4x performance. To me, that's a pretty big win. So you're talking about dealing with, either DDoSes or just huge levels of traffic. Well, if you only do 10 gigabit and you're trying to serve 12 gigabits of traffic, you're in trouble, right? So moving to this platform where you can do 40, that's a huge benefit. And if it's just a flip a switch, you're in good shape.
Mm-hmm. Stevie, will this all make IT easier to manage or more complex to manage? And, what's your sense of maybe now is the time to shift over to managed services, because, we're having this kind of moment in time where everything is going to get swapped out sooner or eventually. But, to what degree do I want to manage all this stuff, or does it become just a service I consume?
From my perspective, I've sort of been on the train for a little bit that managed services, your GKEs, your EKSs and stuff like offer like the incentive to roll your own if you're doing cloud, if you're deploying to the cloud, I think has decreased because I think that the managed services have really like caught up and pretty much offer a lot of the things that you need, and they take on the complexity for you. So like you're not having to think about things like, if you want to do multi-cluster networking, for example, Google has their whole MCS thing, and they've got like, their cloud load balancer. They give you multi-cluster ingress and stuff like that. And that's all stuff that you don't have to set up for yourself. So for me, I feel like unless you have like some really unique use case, which used to be the case for, why I would say, use COPS or something like that to spin up your clusters. Unless you have some like real unique use case, I feel like offloading this stuff to managed services, it makes sense to me because it is complex. And the more that obviously depending on how you're also going to be doing your networking, what kind of clusters you're going to have, where they're going to be, how you're going to split your services among clusters, if you're doing replicated services, if you're doing, the split services, all that stuff, it gets more and more complex as you take in all those all those options. And I feel like, these managed services have things right out of the box that can pretty much help drive you along faster. And I think that will help faster adoption too, rather than folks having to, read through all the docs and figure it out themselves and, do that whole trial and error thing. Go to a provider. It makes sense to go to a provider that has all that, that's done all that work for you, I guess. Does that answer your question?
Totally agree with you too, is that fast time to value lets you focus on solving problems that are revenue facing or, targets based rather than solving fundamental stuff. So I'm very we're in violent agreement, Stevie.
Violent agreement. I would agree here with you guys for sure. It's like, why would I spend all this time deploying my own Kubernetes cluster when I can just click the box, right, and get 99% of my use cases covered? Right? I mean, what's the business? What are they paying you to do? Are they paying you to deploy Kubernetes? Are they paying you to make sure that the infrastructure is at peak functionality, so you can offload your time?
Do you guys think in general that if I look back at recent times, the rate of innovation is faster now, and we are starting to see this shift where it's moving too fast for me to consume, and nobody wants to be the proverbial laggard where they're running, version 72 and everybody else is on version, 3007 because somebody didn't want to upgrade or somebody has some dependencies and things get broken. So have we moved to a point now where the pace of innovation and things like eBPF are an example of that is got to the point where it's really not worth managing infrastructure at this low level because, ultimately, if there's new storage or networking software coming, I want that to be somebody else's problem who has a bunch of engineering talent to deal with it. Is that where we are now? Josh?
I was thinking about some scenarios where, large enterprises will often freeze versions, several, like where we would consider it stable. There's still several releases back. And I think that there is some, like to your line of reasoning, there are certainly cases where using like the latest and greatest, from a security perspective, it's like, that's why our iPhones all update, on their own so that they can, you leave it to Apple to patch out all the things that, that are coming out, and you have to assume that as an end user they're going to learn it first. I don't know. Like I think it, from my ideal would be to how do I operate something as a line of business owner in a way that lets me do the core, less complexity, faster revenue, all that other stuff. So is it out there? To make, I guess, as long as we can simplify it and we have our confidence that what we have is working, then why not move to a more modern system, right?
Mm-hmm. Jared, do you see the same thing happening? And if so, then what does it mean to be in IT going forward? Because, I joked with one guy not too long ago, and I said, what's the difference between, you and a Google? And he said, well, they have engineers and I have administrators. But we don't have enough administrators, never mind engineers. So do we need a different model for thinking about the way we consume innovative things like eBPF? Because we're never going to have enough people to throw at all this stuff. And then the enterprise, as we know, just keeps getting bigger and bigger, more extended. And some people would argue the biggest problem we have with security is just the attack surface is too damn big. So have we just reached a point where we cannot sustain it in this level of innovation without some sort of rethink of how we consume it?
Yeah, I think some people just need to kind of like lower their shields a little bit here. So it's like we already offload so much stuff, right? We're not out there, scraping the beaches for our own silicon and making our own processors, right? Like, we've already offloaded that to the IBMs, the Intels, and the ARMs of the world. We're not running our own kernel. Right? We've offloaded that to the entire world. We just, take it in. So, if you focus on your line of business application where you can actually make money in the parts that you actually write and focus on what you guys can do best, I think there's going to be lots of places where it's just better to pay a managed service provider. Is it either to manage your on-prem cluster or just do it in the cloud? However it is, you're still paying somebody for it and get that and reap that benefit. Just, if they use eBPF to do the processing, that's fantastic. And just, kind of playing on what you guys were saying there earlier about version control and then enterprises locking their releases down to we only run on this version, right? Is what we support. Well, that's kind of the advantage of using eBPF versus writing your own kernel module to handle this. Is like if you can upgrade the kernel and keep that program running without having to rewrite your module every time that you release.
Yeah, great.
So there's places you can invest that money, right? You can invest it in writing this program, and it'll continue working going forward.
That's a fantastic point. Jared, I was going to ask you, do you think that there is a, like a lot of times for early adoption, especially in the enterprise context, it's like, where is that sort of low risk area to deploy this new technology to that's not going to make people feel like, oh man, we're going to crash the whole thing. Where can we put this first? Are we already there for eBPF, or are we, are we looking for that place to land it first?
I think we're there. To be honest, I think there's people out there, who are definitely running this technology and not even knowing it. I mean, how many vendors that are big vendors that people are looking at are hooking using eBPF? The first thing they should change the name. I can't say. That's the biggest mistake they've made. Everything else is perfect. But like Sysdig, Cilium, Calico. I'm not getting anything more, but I'm sure everyone who's doing all this, observation stuff, they're all using eBPF to gather those metrics and make these choices. So I'm sure there's tons of people out there who just installed this and have no idea how it works, which is, the same way I do most of my stuff. And so I have no idea how it works.
Do you guys think that this will become a bigger issue in the land of Kubernetes? Because we are starting to see multiple Kubernetes clusters being deployed by organizations, and maybe we are on the cusp of, heaven forbid, the conversation used to be, when are people going to deploy Kubernetes, to now it's like, how are we going to manage Kubernetes sprawl, because it's everywhere. So is the tenor and the tone of the conversation going to shift around Kubernetes to the point where it also will drive this shift in networking, because we have enough clusters where people are going to stand up and go, wow, I have no idea how to connect these things?
Yes.
All right.
It just kind of, so as you stand up more kube clusters, right, the question becomes, if I deploy service A on cluster 1 and I wanted to talk to service B, well, do you want to go through the front door? Is that how they're supposed to talk? Or are they supposed to talk across the back end, right? And that's kind of where we can use eBPF to hook these two clusters together and actually, have multiple clusters and still have internal communication rather than having to go through the front door for everything.
All right.
And short circuit stuff.
we go
I
ahead.
was gonna say, we definitely have a question in here about, like if that network, and I'm assuming it's the network driver we're talking about here, like versus the traditional native code network driver.
Wait, Josh. I don't know if everybody can see the question, so ask.
Yeah. We'll read back. So the question is, why do we think the eBPF based network driver, which is slower and more limited in scope, will be accepted more widely or better than the traditional native code network driver? So that's the question, and I don't know if I have a really good answer to that. But maybe to focus back on what we were saying about safety, the ability to compartmentalize it, or the ability to, like, if you really understand that bytecode, I don't know. Like I can think of some tool sets that literally bring their own network stack with them. What if you don't have to do that anymore? Isn't that the beauty of segmenting it this way or compartmentalizing it?
And wouldn't it be the same in each, relatively the same in each instance of an operating system, so that you can write it once and have it play anywhere proverbially, and then that becomes part of the efficiency. And now I'm not having some unique stack of software that I'm trying to optimize and secure everywhere, because that seems like a lot of work. But Jared, what do you think?
I think kind of the idea here is that if you can get like 70-80% efficiency, hey, you're doing pretty good. And if you need 100% efficiency, well, then you're kind of playing a different space than everybody else. Like there's plenty of people who work all day, every day using kube proxy. And they, like I said earlier, they're limited to roughly 10 gigabit of transfer speed. If you're not doing 10 gigabits, that's fantastic. And if you move over to eBPF, you get 40 gigabits. Well, if you need 400, you're in a different ballpark completely, right? So then that's where that native code comes in. So like you were saying, Mike, that you get that visibility and you get the consistency across platforms. There's a win. But if you really need high top line wire speed performance, then maybe you need to do that with native code, and that's just kind of a different market. And there's nothing wrong with that.
And that's kind of how it has always been, right? Regardless of whether or not it's eBPF, but we've always had this kind of, general purpose software that people use broadly. And then if you needed something that was high performance or high performance computing, you did something different, and it became, in some cases, that became, industrialized by cloud service providers. But ultimately, there's still large numbers of people who are doing something that requires highly optimized GPC and networking, but they represent maybe less than 20% of the total market. Fair?
I mean, a lot of the world runs on a single process Python program. We're not all writing things in high speed native assembly, just to handle our general web traffic.
So that's fascinating.
Do you guys have any recommendations for people about where to get started with this, or at least learn about it? I mean, I think, one of the things that's always been great about this industry is people are curious and they will go experiment and look at stuff and see what it's about. It may not always be for them, but Stevie, is there a place that you would recommend folks go play around and look at stuff and say, how do I kind of at least get familiar with the concepts?
Oh yeah, I can share like a giant list of links that I went through to familiarize myself with the concepts, because, I'm no kernel programmer, obviously. And, I'm probably one of those folks who may be using eBPF in some way, but not knowing it because of some other tooling that I'm using. And so like, I really had to deep dive into eBPF and understand what it is to get ready for this talk. The eBPF.io, I think, website was a great resource. There is I think IO Visor is a GitHub repo that has a lot of, I think, eBPF programs or plugins there that you can look at to sort of see what it does and how it can be used without being outside of like a giant vendor or something. I think we mentioned Cilium, and I've, been looking into it a lot because it's one of the more vocal businesses using eBPF. So, when you Google eBPF, the Cilium name pops up a lot. But they have very good documentation, and also they're doing a lot of things with eBPF, so you can sort of see the broad swath of ways that you can utilize it. I think those are mine.
All right. Anybody got any other recommendations?
I would just reiterate the eBPF.io is a very good resource. They have lots of tutorials, lots of slideshows, and lots of good documentation.
All right. Would you buy something at this point then that was not eBPF enabled? Is this a new check mark in the box here that we got to have, which says, because it at least says that this thing is going to run at scale or be more scalable than the next thing? And I know we don't all get thrilled with these checkbox approaches to purchasing things, but at the end of the day, is that something you'd be looking for, Jared?
Yeah, I would look for it. I don't know if it's an automatic deny or an automatic approval, right? It just, to me at this point, I would say just consider it, right? It's like it should be something you're aware of, something you're keeping your tabs on, and you don't have to require it, but it's definitely good to know, because that tells you that the vendor is moving, forward thinking and has developed a platform that's going to be performance scalable, right? So if they have an issue, if they're looking at security software and they're monitoring all your write calls, are they doing that with a sidecar and it's all shelling out to user mode's code, or is it looking at this as it's going through the kernel? One of those is going to be much faster and much more accurate.
I don't know, Josh, what do you think? Because I'm thinking maybe you create a little contract that says if it's not eBPF enabled today, I will get an automatic upgrade in 6 to 12 months when it is, and I would bake that into the contract as an automatic upgrade and kind of force that issue. You think vendors would sign such a contract?
I don't know about that. Like I see a number of of RFPs, like out there today, or like checklists that like, here's what this must do, and and like here are the go no go criteria, or those types of things. I am not certain that I'm going to see eBPF at least in where I work, coming into the into the space that I am most frequently working in. But I know it's going to be out there. And I think I'm going to be surprised when it's like, hey, is this eBPF? Because it's not like saying, hey, does this support, SAML2 or OpenID Connect, those type of things. Like they're very easy to put your hand on, and there's a lot of vendors in the space. Here, I think we're still very nascent, despite the adoption in some of the, like in the Netflixes of the world, right? It's very roll your own. Like this harkens back to, supercomputing kind of things from the, from the 80s, where you literally had the people that created the silicon there and knew how to write assembly for them. We're somewhere in between those two ideas is where I think it is.
Yeah. Stevie, how long do you think this will take? And I'm going to reiterate some advice that I had got early on in my career from one of those futurist fellows, and he was crediting a bunch of old cowboy wisdom, but basically it goes something like this: never mistake a clear view for a short distance. So we have a good sense of what's coming, but how long might it take us to get there? And
I put on my Nostradamus hat.
Absolutely.
I don't know. I think.
I think there's a couple of horse races coming up too.
Yeah, follow me for all your betting needs. If I understand the question correctly, I think it really depends on the type of organization, the size of the organization. I think, Josh said earlier, that larger organizations tend to be a little less, a little more change adverse. If they have something that works, that gives them stability, they tend to stick with that. But there are, I think about something like Falco, right? Falco, which I believe uses like eBPF to do its security stuff. And all of a sudden, with where I work, we suddenly had loads of clients, being like, install Falco. And it wasn't that they knew what was going on under the hood, but it was a space that had like a need. Like people were like, we need to start doing something to secure these clusters. So I feel like as companies, I think companies will be fast, software companies will be fast to like adopt eBPF into the way they do things to optimize, their runtime, to optimize their performance. And then in turn, other companies will, be fast to adopt those technologies to help shore up and add stability and security, especially in the security space. Like I feel like that's really a place where a lot of Kubernetes, a lot of focus is in Kubernetes today. Is like, how do we secure these clusters? How do we protect them from all the CVEs that are coming out and things like that? So I think that's like, I feel like it's going to be a sort of snowball effect, right? Like people are going to be eager to scarf up technologies to help stabilize their clusters, and the folks that make these things are going to be quick to adopt new technologies like eBPF, or it's not new, but to adopt eBPF to like make their things run better. And it's just going to be like a kumbaya moment between between vendor, developer, and consumer.
Jared, what's your kind of advice to folks about, is there a safe way to go do this? Or, to your point, there's a lot of eBPF already out there, but, I seem to remember the last thing in my childhood before I crashed something was generally the phrase was, look, ma, no hands. So the issue is, are there things that people should be looking for that's a best practice for implementing this type of technology so they don't wind up doing something that is unexpected or perhaps, I don't know, harmful?
For that thing, I'll go right with what you said. Look, ma, no hands, right? So if you're paying for Sysdig, for Falco, for Cilium, for other product that we're not sponsoring, if you're paying for that, it's probably gonna be all right? But if you have somebody in your org who's like, I read about eBPF, I'm going to write this thing right now, and I'm going to push that to production, that's probably the red flag for me right there. Because you are in the kernel, right? You are working at the kernel, and they put some fences around what you can do, but you're still, inspecting traffic, inspecting syscalls, and you can cause all kinds of problems. So make sure if you're going to do this, it's just something that your org wants to support long-term. And, if you're doing internally, make sure you guys have the knowledge inside to do it.
Like no grabbing programs and plugins off the internet, where someone says, here's this awesome eBPF program that will do this thing. You're like, yeah, cool.
Yeah, you probably should not be installing eBPF programs off your Twitter feed, right?
Right.
Yeah. And yet people, I don't know, it boggles my mind, honestly, when people install code that they got from, there should be something that just says, as an industry, don't take code from strangers, right? I mean, I don't understand what it is that we're doing with all this stuff, and it's everywhere. But it's kind of like, let me just install this plugin here and see what happens. I mean, it's just kind of but I digress. What is, Josh, your thought about, do you think that we are going to see legacy networks disappear, or are we just going to add these kind of eBPF networks alongside, and now I'm going to have 19 flavors of software-defined networks that I used to have that I just migrated to, plus all the guys who are still managing network infrastructure using CLIs, and now we're just going to have layers upon layers upon layers, and this is yet another layer? Or is something profound going to happen where all this stuff eventually consolidates?
I personally don't see some, watershed moment where everybody just sort of flips the switch. I mean, I see this being part of the entire, like, eBPF will be a significant part of how we're doing networks and overlay networking. But I don't see something like, look, there are vendors out there that are still running, Oracle 9, databases, and it's not broken. So, it may not be supported, but it is still functioning. And I think networking is going to run that way until it's pushed to like the point, like where obsolescence of like speeds, that kind of thing. Look, I'm old enough that I actually removed a networking cable called Twinax, to install 10 base T Ethernet. So that's pretty old. I probably might as well be speaking French or something there. But yeah, like those and the real reason wasn't that the TwinX wasn't working. It's that the 10 base T, like standard 10 megabit Ethernet was just so much better that it made instant sense to go there. So perhaps we're going to cross that bridge sooner than I anticipate, but I think it's going to be a patchwork, really. And how do you work with it all? How do you mitigate some of that complexity, or how do you keep the right staff? Great question, right?
Jared, what do you think? I think Josh is onto something. I think, this time next year, we should have Global eBPF Day. We're all going to go together, and
we'll flip that on with our IPv6 support as well, and we'll all be happy.
Hey, that's that thing.
Exactly the problem, right? This industry has long tails for everything, right? We've been out of IPv4 addresses for how many years now? IPv6 has been, RFC compliant for, I don't know, 20, 25 years, something like that. And, it still doesn't have it. So, this industry, they like to hang on to technologies. So there's going to be new stuff, and it's going to be eBPF. Hope they change the name. And that's once they change the name, it's going to catch on, and then it's going to be everyone's going to be using it. But there's going to be long tails where people are still be running legacy layer 2 networking, or old-fashioned overlays like VLANs, right? Like there's going to be a long tail of technology. So there's going to be moving forward. Lots of new players will be using it, and a lot of people are going to continue using the old stuff until you literally pry it from their cold, dead hands.
There you go. Well, we can look forward to super extended BPPF. I'm sure that's coming down the line. And then there'll be ultra super extended eBPF. And we'll just keep going until somebody in marketing figures out that they want to call it something entirely different.
Have we jumped the shark when we put ML on top of BPF?
There you have it. Stevie, do you think that this may be, we're too far down into the kernel and the acronym, and maybe what's going to happen is that there will be this conversation about performance and throughput and our capabilities to address all that. And then, to our earlier points, that's how we get to eBPF, because people will go solve that problem. And I guess what I'm asking is, is anybody really going to get up in the morning and go, yep, going to go get me some eBPF today?
I mean, no. I don't think so. I think necessity is often what dictates the adoption of things for people and for companies. But someone said earlier, there are plenty of companies that are running, single Kubernetes clusters, running just with straight out of the box stuff. It depends on the size. It depends on your traffic. It depends on your workloads. There's all sorts of stuff that's just working fine for people. And you really have to have a compelling story to get folks to shift from a thing that is reliable, that they understand, which I think is especially pertinent in this whole containerized microservices world that we're in. There has to be a very compelling story to get people to adopt another layer of what they will perceive as complexity on top of that. I think. It's going to take more than just that one person in your organization who just loves doing all the new stuff and is like, ooh, let's do this. You really have to be able to convince people. And so until, unless you're a company that's, again, coming up against those barriers, Jared was saying, unless you're suddenly ooh, I am hitting that, that 10 gig limit or whatever, you're probably not going to go out looking for this so I don't think anyone's going to wake up in the morning being like, ooh, eBPF is my jam today, and I'm going to go convert everything over to that until there's an absolute need for it. Until there's a need for it. It's kind of my opinion.
All right. Jared, let's go back in time. You are 20 years old, just starting out.
That's just like last week.
Just like last week, yeah. would you tell yourself to become a networking specialist today, or would you say that that's not a field to get into because it is going to be dropping in so much to the kernel.
I think we've done a lot of this industry where things are going right now. The lines are really blurred, right? Like I mentioned earlier, we're doing white box switching that's running Linux. Well, 20 years ago, Linux was fairly new and was ran on your x86 servers, not on your networking equipment. But now it's running all the way to the top of the rack. So what I tell myself, I'd say, just keep focusing on the cool technologies, right? Like don't pigeonhole yourself and say, I do networking, because what networking is today and what networking is tomorrow are not going to be the same thing. Right? That's kind of that's my advice to myself.
All right, Josh,
I'm thinking of the John Gage quote from Sun Microsystems, "The network is the computer." And I think we see that kind of with a lot of the Web3 stuff that's going on right now, is that, the fact that we're seeing all of this stuff distributed out into the far edges or the leaves of our networks now, where it used to just be centralized. I don't think Sun, and John Gage had that idea when they said the network is the computer. They probably still meant come to our giant iron, computer and do it there. But now, to me, yeah, I'd be a network engineer for sure. Move packets around all day.
Stevie, what do you think?
I mean, I was a network engineer 20 years ago, and I made a deliberate shift to go into a different direction. So, but no, I think I would still tell myself to do that because it is sort of all becoming intertwined. And I think that the knowledge that you get from network engineering, from working at those lower levels of the stack, definitely help inform your decisions about how you deploy and run things at a higher level. And so, yeah, I would say, yeah, go for it. Be a network engineer. Do networking, because networking is cool.
All right. And it may be the start of something else that leads you somewhere else, and you should know what's going on in the network, because there's an old joke that I always do like is, what's the one thing that a data center guy and a developer can agree on?
It's the network.
It's the networking guy's fault. All right.
It's always DNS, right?
That's right. It's network or DNS all the time.
All right. Hey, guys, thanks for sharing your knowledge and insights. This was awesome. I'm going to hand it back to Cody, who's going to do some housekeeping stuff for us. And as always, thank you all for watching this latest webinar, and we hope to see you on the next one.
Well, Stevie, Josh, Jared, Mike, thank you all so much for being here with us today. I'd like to remind our audience that this session was recorded. So following this panel, you'll receive an email with a link to access the recording on demand. You can also find this recording living on the Container Journal website. Just visit containerjournal.com/webinars and be sure to look in the on-demand section. So onto those 4 $25 Amazon gift cards that we are to be giving away. Our first winner is Daryl A. Our second winner is Sri B. Our third winner is Alejandro M. And our fourth and final winner is Carol C. So to 4 of you, congratulations. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. So again, Stevie, Josh, Jared, Mike, thank you all for being here. And to our audience, thank you for joining us for the entirety of today's panel. We just ask for one extra moment of your time to fill out a quick post-webinar survey, but otherwise, we do hope to see you at an upcoming Techstrong Learning webinar. Everyone, have a great rest of your day.
See you guys.